All right, let's get into it. Today, we're putting on our architect hats because our project is to build one of nature's most incredible structures, the human thorax. We're going to assemble this thing piece by piece so we can really understand how it's both a protective fortress and the engine that powers our every single breath. So check this out. This is the thoracic cage. And yeah, at first glance, it looks like a fortress, right? It's this cage of bone designed to shield your heart and your lungs from the outside world. You can see how the ribs curve all the way from the spine in the back to the breastbone right at the front. But that brings up a huge question, doesn't it? If this thing is a suit of armor, how in the world does it move? How can this fortress possibly expand and contract more than 20,000 times a day just so we can breathe? Well, that's the puzzle we're about to solve together. Okay, so every great building starts with a solid foundation. And for the thorax, that foundation, the central pillar that everything is built on, is the thoracic spine. And what's it made of? 12 specialized blocks. We call them the thoracic vertebrae. We count them, T1 from the top, all the way down to T12. And here's the kicker. Every single one of these has a very special job involving our ribs. Let's take a closer look at one of these, shall we? You can see right away they have this really unique shape. From the top, the main body is kind of heart-shaped. And then from the side, you can see this long spinous process that points down. But to really get why they're so special, we need to zoom in on their key features. See, none of this is by accident. That heart shape gives it stability, the hole in the middle protects the spinal cord, but the real magic, the whole reason we're talking about these, are those smooth little spots called costal facets. You can think of them like custom-built, perfectly engineered docking stations, designed for one thing and one thing only, the ribs. All right, foundation's poured. Now it's time to put up the walls of our structure. And in this case, the walls are, of course, the ribs. So here's the business end of a typical rib. You know, the part that's going to hook up to the spine. There are two key parts for our construction project. The head, which has these smooth surfaces, and this little bump right here, called the tubercle. Remember those two parts, because they're about to become super important. So our first connection is called the costovertebral joint. It sounds complicated, I know, but it's not. Costo is just a fancy word for rib. And vertebral obviously means vertebra. So it's the rib to vertebra joint. That's it. This is the main anchor point. And wow, look at this. This is just beautiful engineering. You can see exactly how the head of that rib, with its two little facets, just slots right in between two of the vertebrae. It's like a puzzle piece designed for a perfect, stable fit. It's absolutely incredible. But nature wasn't done. For extra security, there's a second lock. It's called the costotransverse joint, and this is where that little bump we talked about, the tubercle, finally comes into play. This view from the top really clears it up. See that? The tubercle on the rib connects with that little wing-like part on the vertebra. So now you've got these two joints working together, creating this incredibly strong anchor. I mean, that rib is not going anywhere. Okay, so the back is locked down tight. It's strong, it's stable, but we still haven't solved our breathing problem, have we? Nope. For that, we've got to go around to the front of the cage. This is where things get flexible. And here is the secret ingredient, cartilage. See, the ribs don't connect directly to your breastbone with more bone. No way. Instead, they attach to these strips of flexible cartilage. And this little bit of give, this little bit of flex, well, that changes everything. It's the key to the whole system. So you've basically got two totally different strategies happening at the same time. In the back, you've got strong, bony, rigid connections. That's all about strength. Think Fort Knox. But in the front, you have these flexible cartilage connections, and that's all about movement. It's this brilliant combination that lets the thorax be both strong and dynamic. Our structure is almost complete. We've got the foundation, we've got the arches, we have the flexible front. But to hold it all together, especially under pressure, we need to add the final components, the structural cables. We call them ligaments. And we're not just talking about a couple pieces of tape here. This is a whole stabilizing system, a complex web of ligaments designed to do two things: strengthen all the joints and also make sure they don't move too much. They keep everything moving just the right amount. Let's zoom in on a perfect example. This is the radiate ligament, and you can see why it's called that, right? The fibers just radiate out from the head of the rib, fanning out to grab onto the vertebra above, the one below, and even the disc in the middle. It's like a built-in three-point anchor. And what about our second connection? Well, it gets its own security detail. These are the costotransverse ligaments. They're not long and fanned out. They're short, thick, and unbelievably strong. They basically lash the rib to the vertebrae, making that connection absolutely rock solid. And there we have it. Construction is complete. Our foundation is set, the walls are up, it's all reinforced, our structure is ready. So now for the fun part. Let's turn on the machine and watch it breathe. So think about it. You decide to take a breath. What actually happens? Your muscles pull the ribs up and out, kind of like lifting a bucket handle. Those rigid joints in the back, they act as perfect little hinges. And that flexible cartilage in the front, that's what lets the whole cage expand. All that new space creates a little vacuum, air rushes in to fill your lungs, and just like that, you've taken a breath.
And that's the real genius of it all, isn't it? It's both things at once. It's a fortress strong enough to protect your heart and lungs, and it's a dynamic machine engineered to move with every single breath you take for your entire life.
You know, when you just step back and look at the whole thing put together, it's just beautiful. It really is elegant. Every curve, every joint, every single ligament is placed with precision to do those two jobs, protection and motion. It really is the architecture that powers the rhythm of life. So the next time you take a nice, deep breath, just think about the incredible machine we just assembled. Think about it working inside you. It really makes you wonder, doesn't it? What other marvels of natural engineering are hiding inside us just waiting to be explored?